Well, hello, my name is Ana Margarita Gomez, and I'm going to present my stage number 3 of my project. So here we go. One of the motivations when carrying out this work is to understand what factors intervene in the time of an object in free fall. We hope that from this work we can evaluate what Galileo said, that gravity affects all bodies in the same way when they are in the void falling regardless of their weight. From there, we will start with our hypothesis of the greater the weight of the object, the faster it will reach the ground, and the smaller the object, the longer it would take to fall. We will see this through logic, and we will see if this logic is maintained in our experiment. So, come on. In order to determine what free fall is, we must understand that it refers to the movement of a body under the action of a gravitational field. Like this, an apple fall, that's gravity. The variables, this is part of our methodology. The independent variables are the variables that we can control. Here we are going to control the height. Here we have 20 different type of heights, and our dependent variables are the ones that can change, that are dependent of the independent variables, such as the time that it will take from each height to reach the ground. And of course, we have our control variables that are the mass of the two objects that we are going to use from this project. And materials, we use two balls from different mass in order to see which will fall in less time. We use a chronometer, the one that is in the phones, a measuring tape, and a post-it to mark every single height. The results. Our hypothesis was that the object that has more mass will fall faster than the object that has less mass. But in our results, we get it wrong because we have some inconsistencies that the object B that was the object that has less mass also take less time to fall. Also took less time to fall. So it was like, how this happening? And because the air should be working here. So in the 75% of all the falls that we take, the object B always reach the ground earlier than the object A. So this is impossible to the logic. And we can see this with these graphics that I put. I choose to check how it should look if we make this correctly. So I use the formula, and the formula says that it will, so the longer the height is, the longer the time it takes. Here you can see 2 meters, it takes like 64 seconds. But in object A, it is like, and object B is like, so this is an inconsistency because it shouldn't look like this. It should look like the formula. So object A has the more inconsistencies compared to object B. So here we see that our first mistake. We should note that the results obtained according to the formula maintain that greater the distance is, the more time it takes to fall. The longer they maintain something that neither the graph of object A nor that of object B maintains, which maintains several inconsistencies over time, since it does not remain constant as in the graph. So here we're looking at graphic of A look like this, graphic of B like this, and the formula graphic like this. So formula graphic is the correct. Conclusion. In this practice, we carry out this project with letting fall two objects of different mass. And we conclude that we, first of all, to improve this project, we have to use a better chronometer because this create all of these inconsistencies that we can see when we compare this to the formula graph. So here is what I see that is a area of opportunity in my project. So thank you for your attentions and see you out. And here is the experiment by the thank you.